Welcome to day 7 of Introduction to Programming using Python. This is first module of 3 modules under starting your path in data science with Python. In our previous lesson last week, we looked at data structures, a list and other data structures that are there that we can use in Python. We noted that a list is something which is equivalent to arrays. Those of us who might have interacted with other languages like C++, Java, and other languages. So it's just an equivalent, but its implementation is not that of an array. But we use the same concepts of arrays as used in other programming languages. Today, we are looking at functions. We would like to understand what a function is and how we create or use a function. So to begin, a function, we are looking at a piece of code that does a specific task. In other words, when you are coming up with a program, in most cases a program is a composition of some pieces of code, which we call functions. The smallest unit of programming code that we have is what we call a programming statement. A programming statement, that is a piece of code that makes sense, that gives a complete thought. It's like a sentence. And we saw that combination of programming statements can form what we call a block of code. So there are many ways how we can actually have this block of codes. Using branching statements, for example, we are able to have a block of code. Using loops, we are able to have a block of code. But apart from that, we can also group our code. Maybe block of codes can also be grouped in other block of codes. We can nest the block of codes. So we can group our code or our statements in what we call a function. Sometimes we can even group one or more functions in what we call a class. We will not go into classes, but we just want to understand what a function is. So this is what we should take. When we have a program, our program can have so many things that it's doing. We might have a program that is calculating an average, maybe it's adding some numbers together and it's displaying some information. So these 3 things can be considered to be 3 different tasks. Our program is able to calculate some average. Our program is able to add some numbers. Our program is able to display some results. So we can come up with pieces of code that should do a specific task. And these pieces of code is what we can call a function. So it's a block of code or a piece of code that does a specific task and returns, some of them of course returns something, but others return nothing. So we have those functions that return a result. After everything is done, it returns a result, but we have other functions that do not return any result. So in Python, how do we implement a function? Here is how we can do so. Previously, if we wanted to do something, we could just do maybe something as welcome, something like that, and we will run our program. But now we are saying, if we want, for example, to repeat something, we may come up with a function, and that piece of code which is a function, whenever we want it in our program, we can just be calling it. So we don't need it to redo or to rewrite. We can write it once and reuse that piece of code anytime that we want. So here's a very simple example. It might not be so meaningful, but it will demonstrate the concept. A function starts with a keyword def for defining or definition. So it starts with the keyword def, and in Python that is, and we specify a name of our function. So we can call it maybe function for now. I'll just call it a function. And a function name must be followed by parentheses or brackets. So here we have empty brackets for now, but we can also put other things as we are going to see soon. Then, because a function is a block of code, if you remember when we are coming up with the if statements and maybe the while, the for, and other blocks of code, every block of code was the line that starts a block of code was ending with a colon. So the same applies to a function. Because it's a block of code, it will contain some statements in it. So it ends with a colon like this. Then the statements that belong to this should be indented the same way we are doing with if statements and other block of codes, of course. So we are indenting them to show that the statements we are writing belong to this function. So it can be any statement. For now, we can just have one statement which says, I'm printed from the function. Something like that. So our function ends there. And we can run our program in as far as the function is not called. This piece of code will not be executed. This is to mean if I can come here and let me have my shell. I needed to use a shell for this one. So let me open my shell here. So in this shell, we have all those files, including Day7. And I want to run that one. So I can just say Python day7.py. Now let's try to see. I've run the program, but as we can see here, nothing is shown. We need to make a call if we want to run this piece of code. So a function is that piece of code, of course, that is doing something, but it will remain unused until you call it in your program. So to call it, you need to know the name of the function. In this case, the name is func. And to make a call, that name must be followed with the parentheses or brackets. And of course, in those brackets, you can put some data that you wanted to send to a function. In this case, a function is not receiving any data, so we are not going to send any data. So this is how you can just do your call. So we just say maybe func. Then something like that. So this is making a call. Our program, when it's called or when it's run, it will go all the way up to here. When it finds this, it will be looking for a func function, and it will jump to here and will be able now to print the function. So let's try to run here. Now we have I am printed from the function. If we want to run it or to call this one twice, so we can also make another call, and if we run it, we'll be able now to have two statements printed. So the first one called here, it went there and printed this one and came back. Then it went, it came to this line, went there, printed this one and came back. So that's how functions actually work. We are coming up with a piece of code that should do a certain thing, and when that thing is done, it will give us information. So we can make a call for that thing to be done. Then when the execution is complete, it will give us the control back. Then we can continue with our program. So in our program, we can continue as a normal program as we are doing. So maybe hello or something like that. So in this case, it will call, it will print that one. It will call again to print that one again. then it will print hello. So if I come here and run my program again, this is what I am getting. So that's a function. So as I stated, a function can have arguments. In this case, for example, we may have this function to receive something. To demonstrate the concept of a function with an argument, let me take off everything here, and I'm going to define a function called sum. So starting with the word def, and just call it sum, and this sum function should receive two arguments, maybe a, maybe b. It can be anything. Then colon there, and what I want my program to do is just to print the result of the two. So for now, it is just going to print the sum of the two numbers. So I want the sum of the two numbers, which will be a plus b. That's what I want my program or my function to do. So outside the function, I can make a call. The name of the function is sum, therefore I'll say sum. Then inside here, I needed to pass two numbers because I have two variables in my function that should receive the values that I'm going to send. So the first number I put here, like 10, is going to be sent to the first variable in the function. This is our function call. And our second number, maybe 15, that one will be copied or will be sent to B. So here we are making a call. It's a function call. We are making a call. So the mapping is very important. This maps with that. These, we call them, in this case, 10 and 15 are called what we call arguments. Of course, sometimes you can also refer to these ones as arguments, but mostly when we're talking of arguments, we are talking of the values that we are sending at a function call. While these variables that we have in the function header, we call this first line of code, we call it header. So those which are available in the function header, we actually know them, like A and B in this case, we know them as parameters. But it's okay if you can refer to any of them interchangeably as arguments. But if you want to be somehow different from the rest of the people, consider calling these ones the variables in the function header, parameters, the values that we send to the function, arguments. Okay, so in this case, as I said, 10 will be copied to B and 10 to A and 15 to B. So if I can come here and run my program, now it will show sum 15. It's able to take this and this, sending them when they're making a call, copying them here, and they're able now to make these calculations, and we're able to have 15 as our result here. Okay, so that's a function. It's a program. We have learned other programming statements. For example, we learned a programming statement for getting values from the user. So instead maybe of having these values put directly into that, those are raw values, we may ask users, because we want maybe to have this one as a simple program that should do some calculations or adding of numbers. So we may ask users to enter two numbers. For example, we may want to have the first number A, and we say input. So maybe we just say enter A, or enter first number. And B, we can have it as something, maybe enter second number. And instead of this, now we can send A and B. So in this case, A and B are going to be our arguments. And if we run our program, it will ask me to enter a number. I'll say 20 and maybe 30 for the second number. We have an issue. Okay. Let's convert them immediately. I want them to be integers, not strings. They are taking them as strings and just concatenating them instead of adding them together. Okay, so let's do it again. So we wanted 20, then 30, and this is what we are getting, 50. So here we are making a call, and we are using these variables. We are making a call to our function over here. This call does not necessarily mean that the variables in here should be the same as variables in there. Like these variables and those which are parameters, they should not be the same. So the arguments here of the variables in here can be something different. For example, we can have maybe this one as x, this one as y. It's all up to us. Maybe we can just say, can you enter x here? And can you enter y here? So we are saying two numbers. Then here, instead of a, b, we are going to say x and y. So we are sending two variables still. So these are actual values, only that our values are in variables. But those values will be copied or will be transferred to a and b. So we can run our program again, and x, the value of x is maybe 50. Then we put y as 70. Then we'll be able to have 120 as our sum. So that's a function. So a function can have no parameters. A function can have parameters. When you are making a call, the call can be literal values like 10 and 15 put here, or it can be some variables, which means we are getting values maybe from the user or from whatever it will come. But when we are passing them, we can pass variables. So we can pass constants or variables. That's up to us. In this case, in this function, our function just did the printing inside there. But this is not very common. A function should do something. Like in this case, our function is adding numbers. So we may only want our function to do that. We don't want it to print anything. We want it just to do the adding of the numbers. And after adding of the numbers, we want our function to return the value. So it's not showing anything. It's just doing some calculations. Then it should return a value. So most functions are used this way. They are given values, they manipulate those values and return a value. In most cases, a function might return one value. In some other cases, it may return more than one value. But in this case, I'm just demonstrating something that is returning a single value. We are passing two values. Those two values are manipulated, are evaluated by adding them together to get something which is a single value, and we are returning that value to the caller. So in this case, this is our caller. It was called here. So we may want to receive the result that will come from the return statement. Here we are making a call, we are sending the values. But after the values have been sent and manipulated, it will send back the value because we are returning. So when that value is sent, what should be done? So the value that comes will replace the whole of this when it comes back. So whatever value comes there is going to replace the whole of this. So there are two ways. You may print directly here if you want to. For example, you will do something like this. So you are making a call. This is the original call, but we are printing a result that will be returned. So if I come here and run my program and maybe put 30 and put 40, then it's going to show 70 because it's taking 30 and 40, adding them, returning it where this function was called, and in this case the function was called here. So the whole of this part is now going to be replaced by 70. So there are other ways. Instead of maybe printing immediately here, you can choose, sorry, I was not supposed to do this. You can choose to just receive it maybe in another variable. So it does the calling. It is calling a function result comes back. Then that result that comes back is going to be stored in a total. Then we can now have our print statement, or we can use even that total in other calculations if you wanted to. For example, if we were trying to come up with a maybe average, then we can take that total and divide it by 2, or we just print out our result. So we can have something like sum. Then we have our total. So we'll be able to take that value and it will come here. Then we're going to do our total. Let's clear the screen. We are having so much. So let me run my program again. So if I run my program, it's asking me to enter a value, maybe 12, enter a value, maybe 18. Then it will be able to say sum is 30. So that's how we actually implement functions. It's a piece of code that does a certain thing. That piece of code will remain unused until it's called. And when you are calling it, we can send some value. So we have a piece of code of functions that can receive some values, process them, return a value. Others may not receive any value and may not even return any value, but they are all functions. Okay, so sometimes you can have a function that has got default value. For example, if we are coming up with a function that should be used for registration of maybe some citizens in our country, or for some people, a system that should register students. Most of our students might be from Malawi, so may not need to get a country all the time. So if the country is not specified, we may assume that, okay, it's Malawi. But for those which are not from Malawi, they may need to specify a country. So we can come up with a function. Maybe we just call that function register function. So we can say register. And this function is going to receive the student name and is going to receive the nationality of the student. So the nationality of the student, by default, we may give it to be Malawi. So by doing this, we are making it to be a default value. So a default value you specify in there. Remember before we had just A and B, but we didn't have equals. But here we have specified the default value. In other words, if we don't supply any value, then the nationality in our function is going to use Malawi. So if we can have a print statement in here which says maybe something like I am okay from maybe nationality, and let's try to call this one, and I'll just call this one which is register, and I'll call it needs two things. It needs a name, so maybe I can put, okay, let me put my favorite Gateway. Then I can put maybe Angola. So I'm passing two arguments. Ketiwe will be copied to name. Angola is going to be copied to nationality. In other words, it's going to replace Malawi because we have specified the value. So we are going to use the default value. So if we come here and run our program, we are going to have I am Ketiwe from Angola. But if I come here and I just pass one value, register Ketiwe, and I run my program, now I'm going to have I am Ketiwe from Malawi. So it's using that. So in other words, a default parameter is that which want to be used in a case where the value is not supplied. So for a system in Malawi, generally we know most of the people using the system or registering on the system will be Malawians. So we can have nationality already set to Malawi. Please note one thing here, that we cannot have something like this. Okay, name. We cannot. Okay, sorry. Let me put something here. We cannot have something like this. The default parameter or parameter with the default argument cannot come first, then after it having parameters without default arguments. The moment you have started the default arguments, it means any value that comes after it should have default argument. Because you cannot have a parameter without a default argument. No. After you have default value. No, because when it's coming here, it will take this one and put it to the first one, to nationality. And this one will not have a value, because it has no default value. But the way it was before, it was okay, because this one will go to the first one. We don't have the second one, so the second one will take the default value. Another example where you can use default values, for example, is to come up with a program that should be able to calculate the sum of maybe 2 or more values, maybe 2 up to 10 values. It can be 2 up to 10, but I'll demonstrate it with a 2 up to 5. So a program that should be able to add 1, 2, 3, 4, 5, plus. You can think of a sum function in Excel. Sum function in Excel is something like this. So we have sum, okay, and in that sum, you can give it any number of arguments. Of course, you can put a limit. Maybe you can say it can accept up to 250 arguments. So you can give it any number of arguments, provided you are separating by comma. So in this case, we just want something that should accept any number of arguments up to 5. So we can say A, B, C, D, E, F. We could choose to say arg1, arg2, arg3, etc. But here 1, 2, 3, 4, 5, 6. No, I want just 5 for now. So it means we have 5 values. I may choose to put a default for all of them, but maybe the first one we should not have a default. Our sum function should accept at least one value, but we may have this one default to 0, this one default to 0, this one default to 0, this one default to 0. So all of them default to 0. And here we can just return them. A plus B plus C plus D plus F plus A, B, C, D, E. Yeah, so we are just returning them. So we can use them wherever we want. Maybe we can say we want to print sum of, then you can specify how many values do you want. So if you want just one value, a sum of 20, it should be able to give you 20. Maybe you want a sum of 20 and 30. 20 and 30. It should be able to give you, close bracket here, it should be able to give you 50. So you're able to add only 2 up to the number of arguments. In this case, we have 5 arguments. So we can have 20, 30, 10, 15. These ones have 4. Then to be able to give, oh no, here is a mistake. I wanted 10, 15, not what I'm getting there. So I wanted something like that. So I'll be able to get 75. Okay, I can have another argument, maybe another 15 or 25. Then 5 arguments, I'll be able to get that one. But the moment I get another argument, this one is outside, it will not be able to find a corresponding 1, 2, 3, 4, 5, 6, A, B, C, D, A. So the last one will not be able to find a corresponding. So we are going to have a problem there. And the same applies if we choose not to supply any value. If we have no value, we are going to have a challenge there. Because the first argument is a must. So this is something that you do in your Excel, the sum function. You can provide it with so many values. With the just comma separation, it will be able to add those values for you. In Excel, for example, you can have something like equals sum. Then you can specify 10, 20, 30. So these are 3 numbers. It will be able to give you 60. But this, we can still be adding more and more arguments to this function. More and more arguments. So I can choose to have more arguments like 40 and 50. In this case, it will be able to add the values. So we have more and more arguments. So this thing might have been implemented similarly to what we have done here, but they just have so many arguments. Maybe they have 150, maybe 256 arguments, we don't know, but they could do something like this. This is just one way, of course, of doing it. There are other ways, but in its simplest form, that's how you can come up with a function such as that. And people can use it again and again. They can provide it with the data. It will be able to do some money calculations and give them the result. A function can receive anything that is considered to be a valid data in Python. We can send it to a function. For example, we can send it a list. Last week we were looking at a list. So you can send a list to a function, and the function can list down or can use that which is in the list to come up or to come up with a final answer, or maybe to display something else. So here we're going to demonstrate something, starting with maybe displaying the items in a list. Then we'll stop by looking at coming up with a function that should calculate the average of a given list. So let's start by looking at a function that should just display something. So we can call it display. And it's receiving a list. You can call it anything. I can call it maybe just a list. Or maybe I should do, okay, maybe. But it's better I call it something that is meaningful. So maybe these are grades. So I'll call it grades. So it's a list of grades that I want to print inside. So this is a list of grades. I can print this list of grade for maybe grade in grades. Maybe let's print them one at a time. So we can say grade. So we'll be able to print all grades using this function. Then I can call that function. But that function requires a list. So I can have my list as X, for example. then specify the items of this list. Maybe let me just have grades such as 50, 60, 58, 90 and 75 for now. 1, 2 and another one and 63. So those are my grades. Then I can call that function, which is display, and specify the value that I'm sending. But now my value is a list. This list will be copied to grades. Here we know it as X. In our function, we'll be knowing it as grades. So I can try to run this program, and I have a list of my grades. My function, which is starting from here and is ending here, this is our function, is able to list my grades. Something like that. So we can send anything. We can send just a single value, or we can send a collection like a list in this case. We may want our function maybe to be used to calculate average. So like average function that we have in Excel. So I want to calculate average, and this average will receive a list of items, an array of items, and it will take that array of items and calculate an average for that. In Excel, an array of items in most cases are provided using a range. So we'll have something maybe from B1 to B6. By doing this, we are creating a list or array of items. So it will take this array of items or a list, send them to whatever it is, whether it's average or whatever, then it's going to go through them to calculate the average and return the value. So that's what we are trying to do. In this case, there's no any value, so we can just mimic to say we have maybe 20, or I wanted 20, maybe 40, etc. So the moment we have our arguments there, it will be able to pick them and calculate average. So we can do the same here. We want to calculate average. We are going to have our range or our array or our list. Then in our program, we'll start by having something which is sum equals 0. Then we are saying for each grade in grades, we want to use something like sum equals sum plus grade. So we are accumulating the sum for the grade. We are taking grade, adding them to sum for each and every grade. It will loop up to the end. So all the grades now will be added into sum, and we are going to have a final total value of all the grades. Then afterwards, we can now return outside the loop. We can now return the sum divided by the number which is in the grades. So we may not know how many items are going to be sent, how big our array is going to be. So instead of just putting a value like 6 in this case, because we want to use it to calculate the 6, we may want to make it general. In Excel, for example, your range can have only 2, can have 3, can have 4, etc. So we need to make this one also. If we send it with 4, this one knows, like in this case we have sent only 2 values, it knows that, okay, there are only 2 values. So it's taking 20 and 40 to get 60 divided by 2, 30. So our program should also be that intelligent. So we can not just put 6 here, but we needed to put something that is general. So we're going to use the len function that we learned last week, a len function of the list. So we have our grades. So it should calculate how many items are in the grades. Then divide that into sum. The result that we get is the average. So it's going to return that average to us. Okay, so let's call our average here. and we are passing this. For now, we can try to pass that which we have here, 20 and 40. Let's try to put 20 here and 40 there. We are passing only 2 items, and let's see what we are going to get as average. Okay, it will display nothing because we are not displaying here. So let me just have a print statement. Maybe I can just have something like average equals something like that. So we are making a call. We are making a call here. We are making a call here. So we needed to run it again. So it's going to it's showing us 30, similar to what we have here. 30. And we can try to add something. Maybe we can try to add okay, maybe 60. We may try to add 60. Saying it's 40. 20, 40, and 60, making a total of 160. Divide by 3, it's 160, 120, I mean, divide by 3, we have 40. So, it's able to calculate, and here if you can put 60, we are now going to have 40. So, we have implemented something that is similar to what we have in Excel. The more values we give it, the better, I mean, it will still calculate the same. So, we can give 50 and see now what we're going to have as our average. So this average is found by dividing whatever we get by 4. So that's how you can implement functions. And that's generally what functions are. And we're going to be using them again and again. Let's see if we can have something else before we wrap up our session today for the average. I mean for the functions, but generally that's how functions actually are implemented. I think for now we can stop here. The other part I'm going to put it in a separate video where I'll be looking at how we can organize the functions into what we call modules. So the functions can be put together. In here we are just working with only one function, but sometimes we can have a number of functions that are related. They are doing some similar stuff. For example, maybe functions that should be doing some arithmetic calculations. Maybe it's subtracting, it's averaging, maybe it's adding, etc. We can put all of them into one unit, which we call it a module. So we are going to have that as a separate video to do the modules or collection of functions. For now, we can stop this video here.